Okay, grade 9. Welcome to Monday. I'm not here, but you do have a substitute, so hopefully you're being very respectful for your substitute. The way we're going to play this is I'm going to give you all 4 show you knows. You have the blank show you know template in front of you that Mr. Drake passed out to you. So just copy them down as we go through them. Just actively listen and copy down the examples I have. And your substitute can press pause here on the video if you need more time to copy things down. So we're going to start off with the first show you know. It says evaluate the expression in 2 different ways. So the first thing that it asks you to do is to figure out what is the value of 4 cubed times 4 to the 5. So the first thing you should be able to do is solve this without actually using, without actually simplifying 4 cubed first and getting an answer, then finding what 4 to the 5 is, and then multiplying together. The first thing is, if you thought about 4 cubed, we know that it's actually 4 times 4 times 4. Okay? In repeated multiplication, 4 cubed would be this. Multiplied by 4 to the 5, which would be 4 times 4 times 4 times 4 times 4. So when we look at this together, if I removed the brackets and just looked at it as a multiplication statement, that would be 4 multiplied by itself 7 times, which an exponential, 8 times, I can't count. I had 3, and then 5. Yeah, that's right. It should be 4 to the 8. There would be 8 4s that multiply together. So the first way is to simply use what we call repeated multiplication and simplify it that way. And the second way you could do it is actually use what's called your sign or your exponent laws. It says if you were multiplying 2 powers that have the same base, so in this case these are 2 different powers, both had the same base of 4, the law is you keep the base and you add your exponents. And in this case you'd have 4 to the 8. So this is the second way you can do it. You can use this law that you can, if the powers have the same base, just keep the base and add the exponents. So and we can see why that works, because right here in the repeated multiplication we see why it's 4 to the 8th, and we see why this law works. In the second example, we have negative 5 squared times negative 5 cubed. And again, the base is negative 5 because it's been defined by the brackets. So we know that's going to be negative 5 multiplied by itself twice, multiplied by negative 5 multiplied by itself 3 times with the 5 cubed. So really we have negative 5 multiplied by itself 5 times, which would be in repeated multiplication. Or we could have simply used our law saying keep the base and add the exponents, and we get negative 5 to the 5th. The second show you know says evaluate each expression in different ways. So this time we're using division. So this is a little bit more complicated. So if I look at A, it's 2 to the 5th divided by 2 to the 4th. Now, before I actually do this, I'm going to figure out what the answer would be. And 2 to the 5th, if I take my calculator, and I go 2, xy button 5, it's going to say 32. And if I go, well, we know that 2 to the 4th is 1 less than 16. So it's actually 32 divided by 16. I know my answer is going to be 2. Okay, so I know my answer is going to be 2 based on just using straight up standard form division, or 2 to the 1. So we know that the sign rules for division, if the powers, again, have the same base, in this case 2 and 2, you keep the base and you subtract your exponents. Different than multiplication. Multiplication, you added your exponents. With division of powers, if they have the same base, you keep the base and subtract the exponents to give you that answer of 2 to the 1, or just 2, okay? But if I want to see why the other way is so complicated, but we're going to do it anyway. So 2 to the 5th is really this. Okay, 2 to the 5th is 2 multiplied by itself 5 times. So we can think of it as being 2 to the 5th divided by 2 to the 4th. And I'm going to use this big divided by 2 to the 4th, which would be 2 times 2 times 2 times 2. So if I evaluate 2 to the 5th divided by 2 to the 4th, this is what it would look like in a different division format. And this is what it would look like in that division with repeated multiplication. Now here's where it gets a little complicated. I'm going to put, there's 5 terms here. There's 1, 2, 3, 4, 5. And in order to have 5 terms in the bottom, I got 1, 2, 3, only got 4 terms down there. I'm going to put a times 1 in there, just because it doesn't affect the final product. The product's still going to be 16. 2 times 2 times 2 times 2 times 1 is still 16. But we're going to put a times 1 in there. And here's why. I'm going to break this up into little parts. All these parts here like this, and I have this like this. So I'm going to think of it 2 over 2 times 2 over 2 times 2 over 2 times 2 over 2 times that last one, which is 2 over 1. And if I had this as a question, if this was a question given to you out of context saying, what is 2 over 2 times 2 over 2 times 2 over 2? It's the multiplication of 5 fractions. So we would have multiplied all the numerators. We would have multiplied all the denominators. This is how we would have solved it. And we would have gotten, on the numerator, we would have gotten 32. On the denominator, we would have gotten 16. And we would have said the final answer is just 2. But if I actually had the fraction 2 over 2, I would never have used it. I would have just went, well, that's 1. So 2 over 2 just makes 1 over 1. This makes 1 over 1. This makes 1 over 1. This makes 1 over 1. And in the end, I would have just been having 1 over 1 times 1 over 1 times 1 over 1 times 1 over 1 times 2 over 1, which would have left me with 2. So what we want to do here is when you have this, you can basically just put your lines through these as if we were kind of like cross-reducing kind of thing. And we would have ended up with just this, which would have been 2 to the 1, or 2 over 1, which would have been this as an answer and this in standard form. Okay, so we would have been able to get that. I know that's confusing. I know of all the things I teach, this is the most confusing thing. So let's look at the second example. So the second example, again, negative 3 is your base, and it says negative 3 to the 10 divided by negative 3 to the 7th. Now, in terms of how do I get the answer, well, thank God this is a lot easier than where does it come from. I keep my base because the base is negative 3. The powers of negative 3 to the exponents of different. And I will subtract my exponents to get the final answer of negative 3 cubed. That will be my final answer. But the y, and here's what it looks like when I write it all out. This is what I would have if I set it up differently. Negative 3 to the 10th divided by negative 3 to the 7th. So when I write it out in repeated multiplication, I have negative 3 multiplied by itself 10 times. And I'd have negative 3 multiplied by itself 7 times in the denominator. And each one of these, negative 3 over negative 3, just like I showed you when I broke it into something that looks like this, that would actually be the same thing as 1. So each of these I can kind of cross out because I can think of them as making 1. And I'd be left with just negative 3 multiplied by itself 3 times over 1, or just negative 3 cubed. That would be my answer. So when I prove why it works, I have to break it down kind of like that. So the answer for that is this. So here's what I'm going to do. I'm going to give you a new question. So everyone get a piece of paper out. I'll put down a couple questions from the first two show you knows. So the first one, let's go with this multiplied, oh sorry, we'll go 3 multiplied by negative 5 squared. What is that in, I'll ask you to do it in 2 different ways. What is that in repeated multiplication? And what is that in exponential form? Okay, so try that one. And then the other one I'm going to get you to do is, how about 6 to the 10 divided by 6 to the 7? And what's that in repeated multiplication, exponential form? And actually, why don't you also put the answer, since it's not going to be that big, why don't you also put the answer in standard form? So I'll move this over a little bit. Exponential form and standard form, which is just a fancy way for saying the answer. Okay, so for all of these, do repeated multiplication or repeated division, exponential form and standard form. So press pause and give it a go. Okay, so the first one. I'm sure you pressed pause, so I'll wait just in case you couldn't find it. Now you press, okay. So the first one in repeated multiplication, it's negative 5 multiplied by negative 5 multiplied by negative 5. And then we have to multiply that by 2 more negative 5s. So I'm running out of space here, so I'll bring this down a little bit here. Bring it over here. Multiplied by negative 5 times negative 5 again. So we have negative 5 multiplied by itself 5 times. So in exponential form, in repeated multiplication, this is what it looks like. In exponential form, it looks like this. And if we grab our calculator and say negative 5 as the base to the exponent of 5, it tells me the answer is negative 3,125. Okay? So repeated multiplication, exponential form, and that. So what I could have also have done is simply use my sign rules, my sign laws, which would keep the base and add the exponents. And if I had to use my sign laws or my exponent laws, I would have been able to get this answer without having to do repeated addition or repeated multiplication. In the second example, I would have 6 multiplied by itself 10 times. And I'd have 6 to the 10 divided by 6 to the 7. Again, each of these would make 1, so I could just cross them out as almost making like a 0 pair, but they're like a whatever. I'd end up with 6 to the 3rd. So my exponential form would be 6 cubed. And if I take my calculator, it's 216. But if I took my calculator and went 6 this as a cubed, it would say it's 216. So in standard form, it's 216. But I could have avoided all of this if I just followed my sign rules, or my exponent laws, excuse me. Keep your base, because both of these powers have the same base of 6, so the rule would be keep the base that they share and subtract your exponents to get the answer. 6 to the 3rd in standard form, 216. Okay. The third show you know. It says write this, which is square brackets, -3 in brackets to the 4 and brackets cubed. So what we really have is we have a power to an exponent, okay? So it says write it as a single power. So what we have to do is think, well, what does this look like? Well, if I was to say I'm cubing something, I know that if this is defined as the base, I'm taking this whole thing inside there and I'm multiplying it by itself this many times. So in its essence, this is what it would look like. It would look like -3 to the 4th multiplied by itself 3 times. So then I'd have another one of them, and I'd have another one of them. So in this case, just like we did before, this would be -3 multiplied by itself 4 times. And how many of those would I have? Well, I would have, I'm going to infinite clone this here. I'd have 1, 2, 3 of them. Okay, and then I'll just delete this one here. Delete this one. So when I think about what this would look like, it looks like this here. And then this one, of course, would look like this one. And this one would look like this one. So in this case, I have -3 multiplied by itself 12 times. So when I simplify that repeated multiplication, it would be -3 as a base to the exponent of 12. But there's an easier way for me to do that. So if I have a power to an exponent, in this case 3, the rule would be, or the law would be, take your base, which in this case is -3, and multiply your exponents. Because you're going to have not 1 4, but you're going to have 3 of them, which is really going to be 12 -3. So then you could simplify it without having to do all of this rigmarole. Now for the second one, it says 5 times 4 in brackets and squared. It says write as the product of 2 powers. So what this means is when you have a number inside the brackets that is being multiplied, we can think about each of those separate parts being squared. So instead of thinking about, one of the ways to think about it is, of course, saying, well, that's 5 times 4 is 20, and 20 squared would be 400. So we can just simplify the brackets and then get 400. But if we use this idea, it's almost like exponent distributive property, exponential distributive property. Each of the parts inside the bracket must be squared, right? So what this means is I can think of it as being 5 squared multiplied by 4 squared instead. So each of those numbers inside the brackets gets an exponent of 2. So when I simplify this, I get 25 times 16. And if I bring up my calculator and go, what is 25 times 16? It is 400. It's the same answer. It's the same answer we got up here, except rather than simplify 5 times 4 to get 20 and square it, I can use distributive property of exponents and give the exponent of 2 to each of the parts inside the brackets. Okay? So if I evaluate that, it gets 400. So let's think of another one. Just one second. Let's just erase this. And let's just think, well, I'll do the next one and then we'll come back to it. So we'll do C first. So C says -2/5, or 2/5, sorry, is a fraction to the 5, and it expresses the quotient, because we can really think of this as being 2 divided by 5, of 2 powers. So the same thing that we did up here with this question, we're going to do with the question of division. The exponent of 5 is given using distributive property, the idea of distributive property, to both parts, both the numerator and the denominator of the fraction, or if you want to think about it, the parts of the division. 2 gets the 5, and divided by 5 gets the exponent of 5. So when we think about this, it's going to be 2 to the 5 divided by 5 to the 5. Okay, let's just do it first with a calculator. So we know that 2/5 is really, well, I can actually use a calculator for this one. 2/5 is really 4/10. And if I do 4/10 at the base and put 5 as the exponent, I get 0.0001024. I think that's what it was. Let me just do that again. So decimal 4, which is 2/5, to the exponent of 5. Yeah, it'll be that. Okay, and if I think about it in terms of this idea, where each part, the 2 and the 5, get the exponent of 5, 2 to the 5 will be 2, 4, 8, 16, 32. And 5 to the 5, well, I'm not that smart. 5 base 5 exponent is 3,125. So then if I take my calculator and say, well, what is 32 divided by 3,125? It tells me it's the same number I got when I used it as 2/5 to the 5. So either way, I get the same answer. Okay, I know that's complicated, but let's do a couple practice questions, see how we do. Okay, so I'll give you 3 questions. The first one, we're going to follow the same idea as the first one. So I'm going to give you square bracket 5 squared. I don't need to be square brackets, it'll be round brackets because I have negatives. So I'll use round brackets. 5 squared. Now I'll square bracket. Sorry. Oh well. Cubed. So I'll just, whatever. 5 squared cubed. Sorry, I know. I'm in Toronto, so who cares? For B, let's try one that looks similar to that. I'm going to go 3 times 5 in brackets squared. I want you to evaluate it 2 ways. And then for the third one, C, we're going to go a quarter. Let's go cubed. See what you get for an answer for that. Okay. So I'd like you to write it out in repeated multiplication or distributive property of exponents, whatever you can do there for that. And then evaluate it to see what you get for an answer. And we'll see if your answers and my answers gel. So press pause again on the video. And when you come back, I'll show you how to get the answers. Okay, so you press pause, you try them out. Let's look at the first one. So the first one is an exponent to an exponent. Now, if I think about what this looks like in repeated multiplication, it would be 5 squared multiplied by itself 3 times, okay? Or 5 times 5 times 5 times 5 times 5 times 5, which is really 5 multiplied by itself 6 times. So my answer is going to be 5 to the 6, but I could have made it much easier than doing that. Or I could say it's the same base when you're multiplying, keep the base and add your exponents. I would have gotten that as well. But the easier way is when you have an exponent to exponent, it's keep your base and multiply your exponents. It's a much easier way to get the answer. So when you have a power to an exponent, the law is keep your base and multiply your exponents out. Now in B, we have 3 times 5. And if I have that squared, it would be 3 times 5 multiplied by 3 times 5, if I want to think of it. Or 3 is multiplied by itself twice, and 5 is multiplied by itself twice. Or, if I use this distributive property idea, I'd have 3 squared multiplied by 5 squared. Or 9 times 25. Or 225. That would be 9 times 25. An easier way for me to do that would have been, or I could have simply taken 3 times 5 and gotten 15, and 15 squared would have also given me 225. That's another way I could have done it. And the third question, a quarter cubed would be a quarter multiplied by a quarter multiplied by a quarter, which would be 1 times 1 times 1 over 4 times 4 times 4, which is 1 over 16, which is 1 over 64 as my answer. An easier way for me to have done that would be to apply the cube to both parts of my fraction. So instead of having a quarter, I could have 1 cubed over 4 cubed, which would still give me this as a final answer. Okay. Your last question of all the things I think grade 9 students do on the provincial exam, this is probably the one that gives the most grief. It's exponents of 0. And it says evaluate each expression. So the first thing I'm going to do is I'm going to use a law to prove what these are. So if I was to take 2 cubed and divide it by 2 cubed, the law would say because both powers share the same base, the law says keep the base and subtract your exponents. Okay, so in this case, I'd have the final answer of 2 to the exponent of 0. Okay, but if I go back into the original question, 2 cubed divided by 2 cubed, and look at it in standard form, I would have 8 divided by itself, or a power divided by its exact same self. In this case, 8 divided by 8. And we all know that 8 divided by 8 equals 1. So therefore, 2 to the exponent of 0 has a standard form value of 1. Which is weird because it seems counterintuitive. It seems like it should be like 2 or something like that. But any base to the exponent of 0 will always have a standard form of 1. And we can look at that again with a different one. So if I go 3 squared, we'll do squared this time, 3 squared divided by 3 squared, we know that's going to be keep the base and subtract your exponents. So I'm going to 3 to the exponent of 0, not 2 to the exponent of 0, 3 to the exponent of 0. And if I look at it in standard form, it'd be 9 divided by 9, which is 1. So therefore, 3 to the exponent of 0 also has a standard form value of 1. Okay, now there is exceptions, and we're going to see that in just a second. So in the first one, A, negative 5 is in brackets. So this is saying negative 5 is your base, and it's to the exponent of 0. So therefore, I know that any base to the exponent of 0 is going to have a standard form value of 1. And I can prove that by saying negative 5 squared divided by negative 5 squared is going to be a positive 25 divided by a positive 25. That's going to equal 1, right? So, and in exponential form, it would be keep the base and subtract your exponents. So we have negative 5 to the 0. So in this case, the base was negative 5, but even though it was to 0, I had a standard form value of 1. The difficult part is B, because B, people think this is going to be 1 as well, because they think, well, that's negative 5 to the 0, but it's not. Remember, if negative 5 is the base, it has to be in brackets. Because it's not in brackets, the base for this particular one is 5. This is really the opposite value. It's almost like this. This is the other way to write it. It's the opposite value of 5 to the 0. So in this case, I would have to say that since 5 to the 0, or any base to itself, is 1, then the opposite of 1 would be negative 1. So in this case, the standard form is negative 1, and in this case, the standard form is 1. And the only difference between the two is this has brackets around the negative 5, so that's saying that is a base to the exponent of 0. And this one does not have brackets around the negative 5, so it is not a base of negative 5, it is a base of 5, and it's the opposite of 5 to the exponent of 0. Now the other two questions, this one here, this does have brackets around the 5, so this is 5 to the 0, right? The base is 5 to the 0. But this negative symbol out here means the opposite of whatever 5 to the 0 is. Since 5 to the 0 is 1, then the opposite of that would be negative 1. And in the last question, 5 to the 0, that's the easiest one we have in the whole thing. So any base to the exponent of 0, there's no brackets around the 5, but we know that's the base. So any base to the exponent of 0 will have a standard form of 1. Okay, let's try a few of those. Let's just see how we do. All right, I'll give you a couple more. I'll go new page. Let's try 2 questions. I'll give you 2. I'll give you 3. Let's try this one here. Let's try this one here. And let's try this one here. Let's see how well we do with these 2. Okay. So try all of these 3. Sorry. Let's try all these 3. See how well you do. Press pause, and we'll come back and see how well you did. Okay, so the first question, A, there is brackets around the negative 2, which means that is my base. And any base to the exponent of 0 will have a standard form of 1. Now this one's a little trickier. This one has base, the brackets around here. So 2 is the base, 0 is the exponent. So 2 to the 0 has a standard form value of 1. And that negative sign, you can think of it as being the opposite of 1, or sometimes you like to think of it as a multiplier, a negative 1 multiplier. Negative 1 times 1 The standard form value will be -1 for that one. And for this last one, this is around the -2, which means it's the base. Any base to negative 0 would have a standard form value of 1. And the opposite of 1, or the -1 times 1, would still have a standard form value of -1. Okay. I know that was a lot to digest with me not here, and some of you are confused. I can tell. I can see you from Toronto. I can see that you're confused. Um, hopefully, there's people around you that understand what's going on. And if you work quietly, you can work with a partner to help get this sheet done. Don't everybody crowd around Logan and Brooke and all those people. Try and work it out yourself. Be quiet, work quietly, be good. If you are done with your sheet early, you can play chess quietly with a partner, but I know how quietly you can sometimes play. So if you're beyond a whisper, then don't play. But enjoy your time together. Be good for your substitute. And tomorrow when you come back, we'll have another lesson for you to work on, another sheet to do. And we'll see you on Wednesday.